Good morning students, and today let us see exercise 5.4, fourth question. Find the equation of the tangent to the parabola y square is equal to 16x perpendicular to 2x plus 2y plus 3 is equal to 0. Now let us see the solution. And what is the equation of straight line? It is given. Equation of straight line is 2x plus 2y plus 3 is equal to 0. Now bring this as a standard form of straight line. So that is y is equal to mx plus c. Therefore you keep this 2y in left hand side itself. Bring these two numbers that side, it becomes minus 2x minus 3. Now bring this to this side, it becomes y equal to minus 2 by 2x minus 3 by 2. If you cancel this, you get y is equal to minus x minus 3 by 2. So which implies y is equal to mx plus c. Now what is m? Therefore m is equal to minus 1. The coefficient of x is minus 1. C is equal to minus 3 by 2. We don't want this C, only m. And it is given that this is perpendicular to the given parabola. So therefore, perpendicular means we can take minus 1 by m. So minus 1 by m is equal to minus 1 by minus 1, which is equal to 1. So we have to take m value is equal to 1 now. And now take the parabola equation. Now equation of parabola. So what is the equation of parabola? It is given y square is equal to 16x. So which implies y square is equal to 4ax is the general equation. So from this equation you can write 4a equal to 16, therefore a is equal to 4. Now we want to find the equation of tangent to the parabola. Equation of tangent to the parabola. What is the equation of tangent to the parabola? At x1, y1, that is y is equal to mx plus, instead of c you can write a by m is the formula. Now substitute m and a values here, you will get the tangent equation. M is 1. So 1 into x plus a is 4 by 1. So y is equal to x plus 4 is the required equation. If you bring this y this side, so which implies x minus y plus 4 is equal to 0 is the required equation. Now let us see question number 5. Now question number 5. Find the equation of tangent at t is equal to 2 to the parabola y square is equal to 8x. And a hint is given here. Use parametric form. So let us write the solution at first. So from the parabola equation we can get the value of a. So what is the equation here? It is given. Equation of parabola is y square is equal to 8x. So which implies y square is equal to 4ax is the general equation. Equate this to 4a is equal to 8, therefore a is equal to 2. So a is equal to 2. Now parametric form. Equation of tangent at at square, 2at. These are the point for the tangency. So in parametric form. So let us write down the equation of tangent in parametric form is yt is equal to x plus ac square. Now substitute the value of A, and it is given t is equal to 2. At t is equal to 2 and A is equal to 2, this equation becomes y into 2 is equal to x plus 2 into 2 square. So 2y is equal to x plus 4 2s are 8. So the equation, the required equation is x, bring this 2y this side, minus 2y plus 8 is equal to 0 is the required equation. Now question number 6. And the same question you can do like this. If you don't know the formula for this tangent in parametric form, you take this, wherever you are getting y square, you substitute y1. Wherever you are getting x square, you substitute x1. And if you get y, substitute 1 by 2 of y plus y1. X means substitute 1 by 2 of x plus x1. And take this equation, y square is equal to 8x. So it is y1 is equal to 8 of x plus x1 divided by 2. See, instead of x1 and y1, substitute this 8t square and 2at, and further you substitute t is equal to 2. Since here the hint is given, use parametric form. So this is the easiest method. For other problems, you can use this. Now let us go to question number 6. Now let me read the question. Find the equations of tangents and normal to the hyperbola 12x square minus 9y square is equal to 108 at theta is equal to pi by 3. Now let us see the solution. At first it is given equation of hyperbola. So equation of hyperbola is 12x square minus 9y square is equal to 108. Now we want the standard form, so divide by 108 throughout the equation. So if we reduce the equation like this, we get this standard form, x square by 9 minus y square by 12 is equal to 1. Here which implies x square by a square minus y square by b square is equal to 1. Then what is a square? A square is equal to 9. So a is equal to plus or minus 3. Always we will take the positive value. And b square is equal to 12. So b is equal to plus or minus root 12. And this root 12 can be split up into 4 3s are 12. Square root of 4 is 2. So b is equal to plus or minus 2 root 3. So a and b values we get. Now here at theta is equal to pi by 3, a hint is given, and the hint is use parametric form and solve. See, if you know the parametric form, the equations you can go. Otherwise we can follow this easiest method. Let me do like that. In the fifth sum I told you, no, like that way. So first we want to find the point. So since it is a hyperbola and at theta is equal to pi by 3, then what is the parametric form? That is parametric equation is x is equal to a secant theta, y is equal to a tan theta. See, instead of this theta, you substitute pi by 3. So, which is equal to a secant pi by 3. Even we can substitute the value of a also. So, a is 3 here. Is equal to 3 into secant pi by 3 is secant 60 degree. Secant means it is the reciprocal of cos theta. Cos 60 is 1 by 2. Therefore, taking reciprocal, it is 2. 3 into 2 is 6. So x is equal to 6. And here if I substitute, here it is b tan theta. So what is b? 2 root 3 tan pi by 3. And 2 root 3 into, what is tan pi by 3? Root 3. So root 3 into root 3 is 3. So 2 into 3 is 6. So the point x comma y is equal to, or we can take x1 comma y1 is equal to 6 comma 6. Take like this, and now write the equation. So now equation of tangent, we are going to find that first. So equation of tangent to the hyperbola. Now what is the equation? 12x square minus 9y square is equal to 108. See, instead of x square, substitute x x1. So 12x x1 minus 9y y1 is equal to 108. Now at 6 comma 6, that is x1 comma y1 is 6 comma 6. Substitute these values here. So 12x into 6 minus 9y into 6 is equal to 108. So simple, divide the same equation by 6 throughout the equation. So 6 cancel, so it is 12x minus 9y is equal to 108 divided by 6 is 1, 6 is 6, balance 4, 48, 8, 6 are, so 18. And once again it is the common multiple of 3. So we can divide the whole equation by 3. So which implies 12 by 3 is 4. 4x minus 9 by 3 is 3. 3y is equal to 18 by 3 is 6. So the equation of tangent is 4x minus 3y minus 6 equal to 0. Now, after getting this, if we want to find the equation of normal, now you just transfer or alter the coefficients of x and y. Minus 3, or you bring this 3 here, so 3, take the variable as it is, 4, inga kondu vandrunga, 4y, minus irundha plus aakikkonga, plus irundha minus. Then remove this constant by a k is equal to 0. Now to find this k at 6 comma 6, take this value and instead of x and y substitute 6 comma 6. So which implies 3 into 6 plus 4 into 6 plus k equal to 0. So 3 6 are 18 plus 24 plus k equal to 0, which implies k equal to 18 plus 24 is 42. If I bring the value here, minus 42. So k is equal to minus 42. If I substitute here, I will get the equation of normal. Is 3x plus 4y minus 42 is equal to 0. See your book answer, it is given minus 12, that is wrong. So 3x plus 4y minus 42 equal to 0 is the correct answer. So equation of tangent is this one and equation of normal is this one. You take it as a result and write separately. And in the example problem also one problem is given like that. Either you can follow the book method or you can follow this method. Now let us go to question number 7. Now question number 7. Prove that the point of intersection of the tangents at T1 and T2 on the parabola y square is equal to 4ax is a T1 T2 comma a of T1 plus T2. Now we want to find the point of intersection. So first let us write the equation of parabola. Now what is given? Equation of parabola is y square is equal to 4ax. Now equation of tangent at, so what is the parametric point here? A square comma 2at. Therefore equation of tangent at this parameter is yt is equal to x plus at square is the equation of tangent. Now here it is given T1 and T2, the points. So we want to find the point of intersection of T1 and T2. So I can write at T1, which implies remove this T into T1. So y T1 is equal to x plus a T1 the whole square. And at T2 is y T2 is equal to x plus a T2 the whole square. Now if you want to find the point of intersection, go to elimination method. Take this as first equation and this as second equation. You just subtract, x will be cancelled. So first equation minus second equation, which implies if you want to subtract, change all the sign in the second equation. So x minus x get cancelled. Here y t1 minus y t2 is equal to, here it is a t1 square minus a t2 square. Now take y as a common term. Here t1 minus t2 is equal to, take a as common, t1 square minus t2 square. Now use the formula a square minus b square. What is the formula? A plus b into a minus b. So you take y of t1 minus t2 is equal to a of t1 minus t2 into t1 plus t2. Now cancel these two terms. So y is equal to a of t1 plus t2. So y coordinate, we got the answer. X comma y, there y is equal to a of t1 plus t2. Now substitute this value in first equation. So first equation becomes y t1 is equal to x plus a t1 square. Now instead of y, substitute a of t1 plus t2. So a of t1 plus t2 into t1 is equal to x plus a t1 the whole square. Now you multiply this a and the t1 inside. So a t1 into t1 is a t1 the whole square plus a into t1 into t2. So a t1 t2 is equal to x plus a t1 the whole square. Now these two terms get cancelled. So therefore x is equal to a t1 t2. If you want to write the point of intersection, point of intersection is x comma y is equal to, so what is x? A t1 t2 comma, what is y? A of t1 plus t2. Hence proved. Now question number 8. Now question number 8. If the normal at the point t1 on the parabola y square is equal to 4ax meets the parabola again at the point t2, then prove that t2 is equal to minus of t1 plus 2 by t1. Now let us draw a diagram at first to prove this. Take a parabola. So the parabola equation given is y square is equal to 4ax. So from this equation we can understand that the vertex is 0, 0 and the parabola opens rightward. So draw the parabola like this. If I take a point A here, Then if I draw a tangent through A, this is the tangent at A. So the parametric form we can write. If I draw the normal, so it is T1 and it is T2. So here the point A, once again this normal meets the parabola at T2 it is given. This is the normal perpendicular to tangent is the normal. This is B, 0, 0. And this is A, this is the point of contact. That is the tangent. And if it is the perpendicular, then it is the normal. Then this point in parametric form, I can take it as AT square, 2AT. But here it is given, the first point is T1, so I can take it here as T1. And this is the point B. Again, this normal meets the parabola at T2. Therefore, this point is B. B is AT2 square, 2AT2. Now, at first, equation of normal. Straight away, we can write down the formula. Equation of normal at AT square, 2AT. Yes, first let me write down the equation. So y plus xt is equal to AT cube plus 2AT. Now at T1, yes, instead of T, remove T1. So remove T and substitute T1. So y is equal to x T1 is equal to A T1 the whole cube plus 2A T1. Now B of AT2 square, 2AT2 lies on it. Now B of AT2 square, 2AT2 lies on it. So you take this equation as 1. Here it is y plus x T1 is equal to, okay, take this equation, first equation. See, instead of x and y, substitute these points. Now the first one is y plus x T1 is equal to A T1 cube plus 2A T1. Now substitute this, instead of y, 2A T2 plus instead of x, A T2 the whole square into T1 is equal to A T1 cube plus 2A T1. Now bring all these numbers this side. So it is 2A T2 plus A T2 square T1 minus A T1 cube minus 2A T1 equal to 0. Now first take 2A terms common. Take 2A as common. So balance T2 minus T1. And take these two terms. Here A is common and T1 also common. Balance T2 square minus T1 square is equal to 0. Now divide throughout the equation by A. Therefore the equation becomes 2 into T2 minus T1 plus, A get cancelled. So T1 of T2 minus T1 into T2 plus T1 equal to 0. I split this equation into A minus B into A plus B. Now here T2 minus T1 is common. Now take T2 minus T1 as a common term. From these two terms, common term get out. So therefore balance is 2 plus T1 of T2 plus T1 is equal to 0. If I bring this term this side, it becomes 0. So cancel. Now first bring this to that side. So T1 into T2 plus T1 is equal to minus 2. Then bring this T1 that side. So T2 plus T1 is equal to minus 2 by T1. Therefore T2 is equal to bring this minus t this side, minus t1 minus 2 by t1. Now take minus as common, minus of t1 plus 2 by t1. Hence proved. Thank you all.